Hello everyone, welcome to the stream. Today we will continue work on the Glasgow adapter for EEPROM programming, or EEPROM reading mostly. So where were we last week? So this is the status from last week. We have those two connectors for the Glasgow. So if you see, this will basically plug in into these two connectors here. And we are using two shift registers to expand the amount of address lines. And we have data connected directly to the FPGA. And in the meantime, Rachel, the Xmon, she added feature to the Glasgow applet that allows for clocking out or having the strobe pin on the shift registers. So that is something we will be upgrading here. So I have to find a different chip here that also has a latch. Also, I learned after Jared ShareBrained talked to him, we should basically have the chip enable and output enable. It doesn't really matter output enable. I think we can just tie this one, but chip enable we should be able to strobe. Especially because White Quark also told me that she is doing some magic there with timing to be able to extract data out of chips. So this is part of the whole magic stuff, to be able to extract data of deteriorating EEPROMs and ROM chips. So yeah, right before this, we started the segment. I also asked into the community and if someone has some chips for me to test, and Paul Stoffregen said he has some parts, which is very exciting. So let me see what he has on here. A27LV. Yeah, I will have to check the part numbers too, because I'm not very familiar with them. Yeah, and I think if we are sending stuff from Portland to here anyways, I will take you up on the EMP21 offer, and I will definitely I will borrow it from you and then send it back to you eventually. I have to check if mine is programming, but just in case it will be. Because I need the chips to be able to test my programmer, and so I need your package to be here before, and I don't want to do two. So yeah, anyways, you know what I mean. All right, thank you very much, Paul. It's very generous of you. I will that will help with this project a lot. So using both output enable and chip enable. So wait, but she also said they are tied together inside the logic, right? I understood that at the end it only drives chip enable where it matters, because output enable is not hooked up to the address decoder, I thought. That's weird. So, okay, well, okay. So we could use one pin. If it is on the FPGA tied together to the same pin, we can just use the chip enable and hook it up to chip enable, output enable together. Right, Rachel? So basically do this. Because we could save the one pin that way. Oh, okay, that's what you're saying. Okay, cool. So the other thing is we have to get rid of these because we do need one pin here, one. Then we need this second pin, no, the right enable we don't need, but we need the latch. So we need two additional pins from the FPGA. So this will move here, and this will move like this, correct? And then we have this will move here like this, and then we have maybe like this. Move, and we will do this. A latch, and this will be CE dash something. Oh, okay. Thanks for, yeah, they are flipped. I should fix that. CE, I can't use slash, CE pipe OE. No, you can't use slashes. They are reserved, and it doesn't complain about it. So slashes are being used to split naming of sheets. So you have schematic sheets, and the name of the schematic sheet is being prefixed. So sheet hierarchies are being encoded in this. So you don't want to use slashes. You can. It won't break really very much, but it's annoying, so I wouldn't do that. So yeah, CE and OE, will that work? Okay. Oh, then I have it over. A cautionary tale from the end of the era? Oh my god. Yeah, so sheet hierarchies. Yeah, the whole lot. Yeah, I have to end it and start it again. Yeah, I know. I have to do this. Hello. Like this. That will do it. Curious, why did that message get censored in stream? What? Wait. What got censored? I didn't even realize something got censored. Oh, in the Streamlabs, my previous. Oh yeah, that's weird. Weird. Yeah, it had to match something weird. Yeah, shrug. You unconsciously make lewd comments, and we don't even know why they are lewd. It's weird. It's all right. Thank you. Yeah, it's basically what did she say? She said, which is why of the root sheet and the net start with /net. I guess it might have been misconstrued as a like HTML or something. Weird. Is that the net thing? Yeah, it is the net thing. Yeah. Okay, cool. So this is the lewd computer speak. Or something like that. Computer was like, no, shh, don't say things like that. Yeah, all right. For HTML crimes. Aw, poor Aki. All right, so I have to swap these. What did Paul say? You might consider putting a resistor in series with every signal between those shift registers and the device you're programming. That's not a bad idea, just in case. PDL chips like that updated to a newer silicon and became far more sensitive to signal quality problems. Oh, okay. So Paul says in the late 1990s, the PDL chips like 8V22 updated to newer silicon and became far more sensitive to signal quality problems. And so I want to add inline resistors. Good point. Thank you, Paul. Yes, I will do that. So I need to, can I delete this no connect, and then move these. And we should, now we have to change the signal name somehow. Although I can just add the resistor, gang resistors here. Before complex got added, yeah. CPLD, yeah, PLD is a programmable logic devices, right? That's the name. Yeah, that was, so PLDs, then CPLDs, and then FPGAs, and then there's also something between ASIC and an FPGA in between there, where you only mask the metallization. It's like a in-between thing where you have preset gates, and then you C of gates, and then you wire it out only up, so you only have to pay for the mask PLDs? Is that what it is? I thought this had a different abbreviation. Yeah, it is essentially that, sure. But I think there was like an in-between thing between a full ASIC and not. GALs? Yeah, there are also GALs. So gate array logic. I think PALs were persistent or something and GALs were not. But yeah, anyways, I'm not very familiar with this stuff. Sorry. Yeah. You don't have to know this. It's obscure knowledge that the old schoolers have. Power was one-time programmable. Okay. Oh, one time, not even reprogrammable. Was reprogrammable. So Gauss you can wipe. Right. Yeah, basically with the PAL you were blowing fuses to program it. Standard logic block ASICs? Yeah. It's something along those lines, for sure. Okay, so we do not have PKL loaded yet. So let's load the pretty KitKat libs. Projects, where did I put this? Oh, it is a separate project, right? Glasgow add-ons. Although I think I can just do this way. Yeah, I think there is a standard part for this. Device. Yeah, device, R network. Device, resistor. I want to just see the full list, that's why I don't want to just search for it. Network 4 is the, no, I don't want it like this. I want it, wow, they have like in 5 different formats. Wow, that's cool. This is connected. This is just a resistor. Trim pot. Dividers. RPAC, that's what the word is. RPAC 4. RPAC 4. Do I want a, what is the different SIP? SIP? Oh. Oh, okay. So these are the really cool ones that like stick up like a. I will look at this in a moment, Rachel. Just a second. Let me figure out, because I just want the RPack, just the normal RPack, but I want the split one. Do I want the split one? I don't think I care. Wow, this thing is huge. Why is it so big? I don't want it that big. Okay, so let's RPack 4. Is there a small version of this? They don't have small versions of this. Ah, it's so annoying. I made it in my PKL lib though. They should get small versions of the networks or the RPacks. That would be very useful. And I don't think I want this split one. I will just do this. Like this. And then we can take this, move it over here, and do this. And then we can copy. And there we go. So that would do the job. We still need to find a different... Okay, so let's see. Yeah, so this is... All right. Some old gals lying around. Yeah, it's like I would, if I want to play with gals, or with like old programmable logic, I rather have a gal than a PAL, right? Because I can at least wipe it. Because blowing through new old stock PALs seems like a terrible waste, unless I need a PAL for a specific purpose. Then it would make sense. But yeah, there was a plan maybe to do some Glasgow related tools for checking logic chips. That would be really cool, I think. Sherbrain mentioned that before, where you could take a retro computer, pull out a logic chip out of it, put it in a Glasgow, and then test that it is still performing correctly or doing the right thing. I think that would be a very useful feature. So let's copy this. Alrighty. There we go. Right, so what was the other thing I had to fix? So you want, by the way, to pick pin output enable when you hook up signal up. The hardware currently has pin CE held high always. Wait, what? Really? Oh, so I still misunderstood what it was doing. Because, again, I thought White Quark said these two pins are hooked together. Output enable, or maybe it was something different. It was not chip enable, output enable, but something else that she was talking about. I don't know. Okay, interesting. Well, yeah, okay. So should I just name that output enable and be done with it? So that it is not confusing to a user? I think I will do that. And then hook up output enable to here. Like this. But then, wait. Well, we do have resistors in line for Glasgow. Glasgow does have inline resistors for all the I/O. And I don't remember what the value is though. I should set a value here, shouldn't I? I think it was like 33 ohms or something. Yeah. Yeah, I do remember it, right? Thanks, Electronic Eel. That's good. 100R. I will not trigger you all with using my most favorite 100E. Or should I? I find it cool because it's obscure. And people are asking, why is it E? It's like, because DIN standards? I like that, yeah. Yeah. But yeah, 100 ohm is fine. Yeah, it really depends because I will have the parts for the 33 ohm, so I do have them actually even here for icebreaker. I don't know. Should I leave it at 100? We can decide it later. It doesn't matter. Whatever. Wave. Just get stuff done. But yeah, I think we have the pinout corrected now. We still need the latch to be hooked up, so we need to replace this symbol with something that has also a latch. What is the correct series of the 74 chip that has the latch pin? Rachel to the rescue. No, it's like I will look it up. Just give me a minute. I think you mentioned the latch stuff. That's why I'm mentioning you. That's all. 100 electron volts per. It should be like 100 EV. KeV or something, kilo electron volts or something. Yeah. Completely wrong unit from a different realm that vaguely sounds similar but describes something else. What is it, like electron flux in a field or whatever? Yeah. Oh god, yeah. Let's see. Shift register. Logic shift registers, and we need a output type. Number of elements, bits per element. Probably. It's like I'm not. That's the problem. I wish I was more familiar with the 74 logic numbering scheme. But yeah, 74 HC 595. Yeah. Shift registers. Something like this. Yeah, output enable. Yeah, storage registers, TCP. Right. Yeah, that seems like the right part. So 74, yes, so let's go here. Yep. So let's see, can I just place this 74 HC 565? What? No, 595, sorry. There we go. SR clock and then SR inverted clock. R clock? What? and we have negated output of H. That's a fancy part. Yeah, I was not looking at a specific part. There's like a bajillion parts here. 226 volts. Are they all 226 volts? Huh, you're probably right. Yeah, they're all of that. That's cool. Interesting. Because there's no selection here, so it means they are all like that. Yeah, and we can have a nice QFN part, which is nice. That would be perfect. It will tuck in underneath nicely. Pre-latching Q7. Let's see. Oh, okay. So this is basically for feeding through with the shift register. So if you shift the data, you use the Q7S as the output. Yeah. And then this, let's see. Oh, no, this is wrong. Oh yeah, so this would be the 7S. So QH tick, and that is the feed through the shift registers. So if we are rowing them up, then we have SR clock and SR not clock. Let's see, how does this work? What? Output enable I get. Manual reset, I get that. Why does this have clock and this one doesn't? Oh, clear, CLR. Read properly. God. Okay, so that's supposed to be clear. Okay, got it. R clock, SR clock. R clock. What is this is CLK, yes, and then SR clock, and then 0. So this is the input data. Got it. But then we have SR cut and R clock. What is the difference here? What? Is that the strobe? No, oh, that's the strobe, I guess. Shift register clock. So I guess this is the storage register. Yeah, that's a weird name. Whatever datasheet this came from, is either super ancient or just weird. Oh God, yeah, that's the part. Let's see. It's not December 1982. Revised September 2015. So this datasheet it was made first in 82, which is fine. Yeah, if the time work, yeah. But it's like the naming is not very clear to me at first. Yeah, so this is where the names are from. So serial, and then we have R clock. So yeah, this is for the buffers here. For the latches. Okay, cool. Yeah. So it is what it is. Oh yeah, the best ones are like actually scanned in like you get a PDF. It's actually not a PDF, it's actually a bitmap inside that someone scanned in. Well, some of them actually have OCR like overlaid over the bitmap, so sometimes you can actually copy and paste stuff still. But it's super weird. Yeah, got that. All right, so let's move this out of the way. We can delete this. Delete this. Then we should make some more space here. There we go. Okay, so clock goes here. Then VCC is up here. Serial goes here. Dash, CS trivia of the day. Wait a second. So for what it's worth, OH like prime is normally read OH dashed. Well, dashed or yeah, I think I learned it as prime. I don't know. Yeah, you might be right. It really, yeah. Yeah, okay. So I'm not super confused today. Good. What? What am I doing here? There we go. And our clock, output enable. So the output enable we keep powered, right? So actually this was, and we do this. Oh, wait. Yeah, because it's negative logic. Yes, you're right. You're right. Correct. You are correct. And then the clear should be powered, right? So clear, I'm not sure it is internally pulled or not. Yeah. Yeah, it's probably not pulled internally. HomeLab OS. Do you have a working OCR software for it? Oh, yeah. Okay. Oh, cool. Thanks, Jordy. Yeah, that might be useful to have. I did look a little bit for OCR software. There are some online things, and half of it looks like a scam. It's really not good. Where you're like, you are just trying to finagle some data out of me, I have the feeling. Okay, output enable latch. So let's copy this. So that will be our latch. Cool. So now let's double this up. Oh yeah, the OH, this should go here, and we have the output. And this should be not A13. That's the important thing. Oh, that's where. How do we name this? A clock, ASI tick, right? Tick, right? Will that work? Yeah, I think it is acceptable. Glad you agree. Okay, let me move this. Field reference. Then move this field value. It's making me grumpy here. This looks horrible. Maybe like this. Something like that. something like that. Okay, then let's copy this. And this one is disconnected because we don't feed more. And then move. Oh yeah, I should also reorganize this. What? Oh, it doesn't move. Interesting. Should realize that it is overlapping, huh? Nope, not value. There we go. Yeah, so there's some Linux software that or open source software for OCR too. That seems to be, but did I use this? I thought I might have actually set it up at some point. I barely remember that. I think my father-in-law needed it at some point. Clock, and this goes here. Like this. This one, clear. Well, yeah, I like this stuff to be easily readable, and so it ends up being a mess if you don't have enough space here. It's like the distances are not just great. I think that's acceptable, I guess. I could scoot it down to yeah, whatever, it's fine. It's all right. Oh yeah, and the output enable actually goes like this. And then copy. There we go. I see. Tesseract. Interesting. Yeah, I think OCR is still like a problematic thing in many cases. It's yeah, the situation is not perfect. It's better. I think it got better. There's I see. Huh. Yeah, we should try that at some point, because this is I'm sure I will need that at some point again. All right, so serial. Let's focus here. Copy this one, and then latch, copy, latch. Good. Now, do we need to move stuff around here or not? It would be nice to name these nets something not horrible. Yeah. Oh, apropos. There's so many new people here, so let's say hello to them. Yeah, Hackerman, thank you for the follow. Welcome to the stream. Same to Guegu and Chamihai. Thank you very much for being here. Welcome to the stream. And Lara Mikkel, thank you for the subscription. Thank you so much. Oh, I appreciate that. Thank you for the Prime subscription. That's great. Thank you for supporting this. This is good. Appreciate that. Yeah, there are a few different OCR tools, I think. There was some common one that is open source and you could build something, but ended up The problem with that was it just requires so much rejigging to put together. It's really annoying. And the software that you can pay for, it's just felt really, really weird. It's like it would need to be tested before I can believe that I can use it. Anyways, also I don't need it that often, so buying a license of an expensive software kit for OCR, I'm not sure I need that. Okay, so we have this. This is done. So let me see. 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. There we go. Should be good enough. Anything else? So data is there. Addresses are there. Do we have the addresses in right order? 0, 1, 2, 3. Should I flip this around? Well, we will see how the routing goes. I'm sure we can flip stuff around if necessary. Then we have 3, then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There, someone in the comments for my last stream mentioned that you can create new labels and they will increase in number if I press insert. So if I copy this and press here, then what happens if I press insert with this? Huh! Wow! Insert creates new labels. That is cool. And then insert. Oh my god, this is cool. I didn't know that. I learned something. So yeah. I just don't know where I have it on this keyboard, where insert is. I would have to figure that out. But yeah. Yeah, I know it where it's on a normal keyboard, not on this one. It's probably on an overlay somewhere. Either in the numlock block or somewhere similar like that with FN. But yeah, you can create numbers. It's a new lesson I learned. That's cool. I heard about this issue before on Windows, that people could not find the plugins anymore. Well, port QMK to the keyboard I/O. I can flash a different firmware on it. But yeah, oh yeah, you would be able to tell me what the overlay is. Let me see. Just let's go in a short tangent. I have the legend somewhere. So let's see. These are the overlays. There we go. So that's the FN overlay here. Insert is X. Interesting. So FNX is insert. And then you have the mouse. Mouse clicks are here. I never use that, so that's why I don't know. Yeah, and this is the same also on Dvorak. I have Dvorak currently loaded, but the overlay is the same. And home tab, like a second tab. Interesting. So there's a second tab here. Then you move the mouse with these, as far as I understand. So up, down, left, right, whatever that is. And then print screen, yeah, Z. I used that in the past, insert. And then audio controls, arrows, fast forward, then I use these, obviously, in the pipe, yeah. Oh, yeah. Yeah, that's cool. Yeah, build service? QMK configurator. Yeah, this is similar to the keyboard I/O system. The Chrysalis, they also have a software like this that you can use for creating the configs and then loading them. Oh, you can load it. That is for the Model 1. Ah, interesting. The QMK configurator. That's cool. So you do. Cool, cool. Yeah, I could give it a try at some point. That would be fun. Yeah, I just laughing in my head. It's like, oh, let's not break the keyboard. But on the other hand, it's like, yeah, I have two. It will be fine. It's like I can always reflash it. It's not a problem. I know how to do these things. But yeah, no, that's cool. I'm glad to hear that. I will give it a try at some point for sure. Okie dokie. So, hi Floyd, thank you for the follow. Welcome to the stream. All right, so now we need to, I think, start adding footprints to this because I think we have everything here. Oh, right, we have to do the jumpers for the address 15 because this one can be jumpering. Yeah, the shift registers, we can remove this. Yeah, we need this. We need to be able to jumper this either to and 14? Both? Okay. Let's see. To allow for yeah, I know, Electronic EO. Programming would be nice-ish. Yeah, I don't feel very good about this because then we are getting into really making it a full-purpose device. So the high voltage input and a switch with one of the leftover pins of the shift register. Will that work? Well, we could adapt the applet to do that, I guess, to have like an additional address line to switch on and off the 12 volt. Yeah, but like, yeah, generating the 12 to 15 or 15 volt VPP, well, it's not fun for sure. I don't know enough about this. That's the problem. And if we are getting into a full functionality, yeah, I know. That was my thought, like having an external power supply for this. I'm not giving in yet. Not today. Maybe next stream I will give in to your request, Electronic Eel. I'm still staying strong for today at least. But yeah, no, I do like the idea of being able to program too. We might add like a transistor switch to be able to switch on the VPP power. So yeah, we have A15. So A15 and 14, Rachel, both of them. And they have like different functions usually. They're like write protect and VPP or something. So they have to have both like a three-way switch, right? Ugh, okay. Grump, 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 grump. Not likey. All right, so how do we do this if it is a three-way switch? So we need like a 2x3 pin header to do the jumpering. Yeah, I know. Connector, generic, 2x3. And we need 2 of these. Okay, so this. For the 2 address lines, A14. So A14 and A15 both need this, because one will go here. So that would be just address. This one will be, yeah, you're probably right, but it's like, are you sure? Get away with a 1x3 then? Okay, wait. So A14, if it is per address line, yeah, but I think Rachel is saying that we should be able to use just a 1x3. Oh, for just 2 modes. Okay. I see what you're saying. So 1 for address, 1 for ground, or like 1 for 1 get that so 1 for program. Wait. Yeah, I can either hold it. Oh, you can hold the address line high and then pull it to ground. Okay. To be fair, though, because we now have latching shift registers, we could implement all of that in software. Right? Or is the write protect so sensitive that that we have to make sure that it is always disabled? Maybe that's the issue here. Yeah, so we theoretically don't need the jumpers anymore if we could do it in software, like set them into the correct mode, right? So this having a 2-way, yeah, I agree that this should be a 2-way jumper. That makes things easier, if anything, if we need one at all. The advantage of having a jumper too is we can rewire it better, I guess. But yeah, with the shift register, we should be able to set those lines to a certain state with each latch forever. So that should be possible. So in theory, we don't need to do that. So yeah, okay. Pin header, connector, generic 1x3. And then we have, this is the output. This is the address, and this should be pulled to ground, correct? No, pulled to ground or pulled high? Because are they negative logic? Pull high, okay. Thank you. Then I should probably just rotate this guy. Is there a specific jumper symbol maybe that is nicer? Jumper dual, passive, jumper to bridged, open, bridged. So this one, these are SMD ones. Maybe we will do this to also indicate what the default state is, right? Well, let's do this. So let's do this. Let's do this. Have it all in line here, and then VCC here. No, and it's not default pull-up. I'm wrong. So, I want it on x-axis, x, like this. So default should be A14 and then VCC. And then we call it what? I need a name for you. A14 tick. Not sure this is correct. Because it's not. It's like actually pin 27 or P27. 27. That would be more correct. And this should be pin 1. How do we call this? Pin mode. Pin mode or something. Then copy. Yeah, we don't need this to be that long. Okay, and then this would be P1. Okay, and then let's move this. There we go. Okay. Yeah, so I will add that as a note here. Let's call this. So P27 is can either be PGM or A14. or can be. Let's do this way. And then let's copy this, and this can be 15 VPP. VPP. So what happens on the VPP? Do we need to have VPP pulled to ground when it is not needed? Yeah, the 256 and the 128. Yeah, the 128 has both pins. The 256 doesn't have the program pin, and then the 512 has neither of them. So yeah. Yeah. That's what I was thinking. So let's do this crazy thing here. And then put ground here. There we go. So for what it's worth, if you have a chip that you want to program, that's to electronic EO. If you want to program this, these will be pin headers that you can force to a different mode if you want to, by connecting this to ground and feeding in 12 volts or 14 volts on here by jumper cables. So you can still program with this if you jerry-rig it correctly with some jumper cables. So it is possible. Yeah, cool. Yeah, I don't know. I have no idea how the programming process actually works, so I can't tell you. Yeah, I would assume you just put 12 volts on it and go at it. I would guess. Yeah, you just power it to 12 volts and then start programming. So I guess you can just power it on, do the whatever, and then start Glasgow to do the programming part afterwards without like a special timing thing. Yeah, let's try this. That should be a good experiment. If we need control over this using the shift registers, yeah, sure, then we can do that. We still have 4 pins left here that we could do stuff with. Do the thing? Yes. Oh yeah, I like that. It's like, then it will be a different type of Alexa calls. And I triggered your Alexa now. Haha. Yeah, there you go. I'm such a horrible person. Triggering your Alexa. Can't stop. All right. Where do I want to do this? Okie dokes. So I think we did this. We did this. So the to-do is pretty much empty for now. Now we can add footprints here. How do we do this the most stupid way? Let's do it this way, or maybe this way. Oh, I have to do this on both of them, so it is better if I do this way. Okay, footprint, and then connector. not DIN connectors. Pin socket, pin header, pin socket, 2.54, 2 times 10, right? Oh, have a good night, Electronic Eel. Sleep well. It's very late for you. Oh, I'm sorry, Timon. I'm sorry. Your work is bad. I hope this will be over soon, and you can take some proper vacation weeks out and relax. I hope you have some vacation days saved up this way, and you can just take off eventually. Take care, my friend. It's yeah. Well, you will. I really hope you can basically say it's like, I'm out. I need my vacation. I'm out for a month. At least in Europe, you get proper vacation amount usually. But then you have to. The hard thing is, especially working for a small company. I remember that from way back when. And it's like, it's really hard. It's like, because when you leave, the company falls apart. It's like, oh, we can't do anything anymore. Work like a quarter. Yeah, but at least take a month off and leave and be like, guys, I will be completely useless to you when I'm completely burned out. So take that. Yeah, I'm sorry. I feel you. I can really relate to that. It's hard. All right. So, what did we say? We said 2 times 20. Is that correct? Yeah, 2 times 10. And yeah. And then we go pin socket, pin header, vertical, 2 times 3. There we go. So that's for the jumpers. Resistor networks. Resistor SMD array. Convex or concave? Jesus. Concave. Convex. Yeah, I want the convex ones, right? I have to make sure. 4X0402. Yeah, I want the convex. SMD, there we go. Apply and save. Now the 74HC595. I would love to use a QFN package for this. Please, 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 give me that. Yes, that's a nice 16 DHV QFN. Neat. Oh, there are different ones. Interesting. From TI. So we have this one. This is Nexperia. Yeah, I think I prefer Nexperia to TI. I'm not sure I prefer this kind of footprint. Oh yeah, the advantage is probably how the pins come out. Let's see. Let's look at the pinout on this. Yeah, I'm not really hating on TI per se. Usually Nexperia is slightly cheaper though. That's the reason. But it's more of a gut feeling. I don't really have data for it. Yeah, they're usually a little bit more pricey. It's different with their SoCs or like microcontrollers. It's like TI is really doing some really annoying stuff in that realm. And I'm talking about the programming interface. Let's not get into that. It's just TI being TI, brewing their own tea in the corner. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, do we have pinout here? Oh yeah, we do have it. See you, Jordy. Have a great day. Enjoy. Talk to you soon. I will just set these footprints and then move on. So yeah, I think the pinout should be compatible with what we have here, right? With the symbol. So this is fixed, the pinout. Yes, it is. So let's compare this. So pin 15, 1, 2, 3, 4, 5, 6, 7. Oh, it is different. There we go. So 1 is 15. 1. Yeah, it's different. Oh, wait, here. Oh, okay, sorry about that. This is correct. I'm looking at the wrong part. Yes. QA 15. D, C, D, E, F, G. Yes. QH is 9. Yes. And then OE 13, correct. 12, 10. What? 12, 10 is MR. Yes, then 11 S clock. And 14 DS, data input. Yes, correct. Okay, so good. And now let's see how that... Oh, there we go. There was a better picture here. Where is it? I just saw it. Yeah. So Q0 is on the other side here. That's not great. Okay. Most of them are on one side. Q1. Yes, that's a little bit weird. It's not terrible. I've seen worse. That's true. It's just like from routing perspective, it's like, why couldn't you just scoot it like there, something? Put the ground here, QS on this side, and then have the 0 here. Like have all the outputs on one side of the chip. Yeah, I know. I'm sure there's a pretty good reason. But if you could just put ground on the 9, then Q7S on this end, then you could scoot all this and have Q0, 1, 2, 3, 4, 5, 6, and 7. Like this. So, yeah. But then it's not really compatible, and it's a different pinout then. Yeah. Osama, thank you for the follow. Welcome. And Goey, Thank you for the follow. Welcome to the stream. Awesome. Anyways, so yeah. Well, for chain. Oh, you mean for chaining? Oh yeah, they would be on the same side. Yeah, DS. DS would go to DS. Yeah, the chaining is not the... Yeah, it is a little bit weird. Okay, anyways. So let's DHVQFN16. I think we will go with that. QFN. Does it say... Would it be a thing, even? So... Oh, God. QFN16, VQFN16, 12, 16. So these would be just these, right? I think I've seen it here at some point. These are QFNs. TQFNs. These are also square. PVQFN. These are also square. Ah, there we go. This is close. Not exactly, but close. UDFN. These are these really tiny ones. Yeah, not exactly that name, but the compatible footprint should be there somewhere. I feel like I've seen it before. That's why I'm looking for it. Doesn't mean it is there. Might be just my pure imagination. Because I see that footprint a lot in different parts. It's like level shifters. There we go. That would be it, but it's not. It's because it's a 20, not a 16. I guess I will have to make it. Oh, okay. Well. I wish the submission process was easier. This is something for a person that wants to have a I don't know, a summer project or something. Build and write and build a web service for submitting footprints for KiCad. Where you can have the auto-generated 3D models, auto-generated footprints with yeah, no, I do like making footprints. That's not the point. But it's like there's so many footprints that you always have to add and review and whatnot. And the process of submitting it to KiCad requires you to do like a 3 repository yoga, where it's like you have to write a generator script for the footprint generation library repository. Then you need a 3D model generator script or parameters for that repository. Then you have to generate both and submit pull requests for the footprint library and the 3D model libraries, which are also separate. So you have 4 repositories that you have to create pull requests in, get all the approval and comments in from the creators, and then it gets merged one by one by one. And it works. It's not terrible. It's definitely better than it used to be, but it's still very annoying and time consuming. So having a central service where it's like, this is the new parameter I'm adding from this datasheet for reference, and then it just generates the stuff from those parameters that you have in a database somewhere, and you have a interface to like shows you the previews, and you can review this stuff. Great, but it's a lot of work to build that. Could fit in the EDA. Well, it requires, I think, some cloud type of service where you can submit this upstream with, yeah. It's all doable if you have the resources to write such a tool. You know, it can be living inside KiCad in some way. I don't mind. Could be like an additional application for managing footprints in a database. That can be cloud connected or not cloud connected. So again, you can then start spinning out into featureism ad nauseum. So anyways, Okay, so I guess I have to make my own footprint. And this one is already dip. So these are dips. That's interesting. I don't want a dip. I want so 27. Oh, this is dip. No, this is correct. Yeah. This is the footprint for this. So that's fine. So the last thing I have to do is make the footprint here. So I have to create a new library locally, unless I pull in PKL. So what do we do? Let's create a new library. New footprint using footprint wizard. That is the correct thing. And we need a QFN, and then we have can't do it. Really? We can't make footprints for. Yeah, so Doey, sorry, it's so we are making a PCB, like designing hardware here. So, oh, you tried and it didn't work. Oh, that's a bummer. So the script needs work. Where did it lock up? I usually do, as far as I can, create the footprint using the wizard and then modify it to be actually correct. So width would be, so pads, what is it? Oh yeah, that is the problem, I guess, because you cannot have uneven count or something. I think I have it in PKL somewhere anyways. Yeah, you can set one side to 5. Yeah, so probably I can make a much bigger and then squeeze it back together. But anyways, let's load the PKL and see what I have in there, because I have the feeling I made that footprint before. So to do that, I need to go lib, and then pretty KiCad libs. There we go. And then I go into hardware. Oh, shit. That was not what I meant. Crap. Can I delete this? How do I delete this? Add, move. Can I just move it maybe? Submodule dinit. Update, set branch, set URL, summary for each async. Add, I get it. Git move, I guess. Yeah, I think that worked. Oh yeah. Oh wait. Lib. Yeah. That has to be fixed. Oh god, I hope that works. Yeah, it didn't rename it in the Git modules though. It didn't affect that, but path was corrected. So I guess only the submodule name. Oh, maybe just the submodule indicator was not being corrected or something weird. Oh yeah. Anyways. Okay, and now hardware from add-on, and then CP icebreaker. Let's just copy it. Projects icebreaker. There we go. Icebreaker hardware. Hardware version. Bitsy, that's the newest 1.1a, and then fp lib table here, and then symlib table. There we go. Yeah, it should still work even if the name was incorrect in there, but that's fine. Okay, so now save, and then close this, and this should now preferences, symbol libraries, where they added project specific ones. It should be here. There we go. Okay, so that worked. And then let's see, not this one. Footprint. Let's see. PKL, is it added yet? Logos mechanical. Oh, it didn't load everything yet. Why is it sorted so weirdly? You know what? I will close this. Cancel. Let's restart this just in case it needs to like reload some weird cache. There we go. Let's see if it reloaded it. Now it's correct. There we go. DFN QFN. No. Yeah, I will have to draw it. Oh no, there we go. I knew I had one. Okay, there we go. Okay, cool. Okay, so we are good. So now let's do F8, annotate, update PCB, and close. Ba-bam! Exciting.
flip, then move. What? Oh. Move, flip, and then move, flip. So every, move, flip. So that will be there. And then move, flip, there, move, flip. There we go. Oh, this, see, I will have to rejig this. The order of the pins is bad, but yeah. Move. So we want, the question will be which one is which. I have to figure that out. And I was thinking of the jumpers going on the bottom there. There we go. Something like that. And then move. So that should be the shield. Something along these lines. Yeah, well, this has only, like, it will be that close. Just saying. So this will be very, very close on the hat. I already looked how it fits, and it's very, very tight. Yeah, I know that's what you're saying, but like I don't really have a good idea where to put them otherwise, like except here on the edge, on the bottom. So if you look at my here, so this is how much space we have, and the jumpers have to go somewhere. So where do I put the jumpers? I either put them here on the top, like here somewhere, or here on the bottom somewhere. But then between here is not really much space. It's like one header wide. That might work. I could try doing that, but I have a lot of traces to run, and I would like to keep it as a 2-layer board if possible, because it's large. And you need access from the top for this. And all the SMD parts will be here on the back. Not under the header, but on the opposite side. So yeah. Yeah. Well, we will be definitely continuing research here and figuring out how to route it in the next stream, because we are done for today. So yeah. There we go. So that's the status for this week. We got quite a lot of work done. This is what takes most time, like figuring out wiring and like details over details. But yeah, we are almost here to the so the idea is this design of this board will be meant as a reference, but you are correct. It would be nice to have a footprint template for the Glasgow add-ons, sure. The idea for this project, it's like one of the main motivations is to have a reference project to take, modify, and use for your own add-ons and breakouts and whatnot. So that is the whole thing, is in that direction. But yeah, I might make a board outline footprint. I've never really used the KiCad template design stuff, so I'm not really familiar with it. And like, there was one for Arduino or something. I never really used them as such. But yeah, I find usually a project that is close enough and I can work on and modify, or I start from scratch. But yeah, No, you are still correct that we should have a footprint for Glasgow add-ons that we can use in designs as a reference, because you can just drop it into a different design in some cases. So yeah, that is it for today. Again, as always, thank you very much everyone for being here. So I appreciate that you're here and hanging out with me. As always, I would like to thank everyone who is subscribed to these streams with Amazon Prime or other means of subscribing here on Twitch. I really appreciate that. That is very nice. That does help with keeping these streams coming every week. Yeah, I really appreciate everyone who is here and gives their input and hangs out and helps with the design. It's really nice to be able to work on a project and have the big brain of the internet be part of it, and all of you definitely contribute to that. So I really appreciate that. Thank you so much. I also would like to give a shout out to the Patreons that are also helping with the with some cash and help out with these streams. So big shout out to Jamin, Aki Van Ness, Ben Venick, Brennan Ashton, Drew Fustini, Edward Borden, Go Jimmy Pie, Jeff Wang, Jordi Paki Rodriguez, Kelly, Matti Schmieder, Matthias Pritchett, Miha Benovet, Sid Price, Tom Keddy, Sean C., Jonas Kudat, Mr. Jake 22, and Ben Baker. So thank you very much to everyone. And I see you next Tuesday, where we continue work on this project and have another community updates. In the meantime, join our Discord and discourse, both of the things, and I see you on the interwebs. So as always, if you have been, thank you for watching. Bye.